very crucial in the field of embedded systems. So many embedded systems will be making use of these bus level protocols, which we are going to learn about. Among them, you have already learned about one, that is the UART's bus level protocol. You have learned about that, and you have gone for implementing that also. So UART is one of the very prominent bus level protocols which is used in the field of embedded systems. In addition to that, we have other popular bus level protocols like what we call the I2C bus level protocol. We have the SPI bus level protocol. We have the CAN bus level protocol. We have the LIN bus level protocol. We have the one wire bus level protocol. We have the Modbus bus level protocol. So there are other bus level protocols also, but right now in our agenda we are having two of the most prominent bus level protocols which are being used in the field of embedded systems. Okay, so they are the I2C protocol and the SPI protocol. So first we're going to discuss about the I2C protocol, and discuss about the protocol. We'll discuss about the implementation of the protocol, the testing of the protocol. Okay, and after that we'll move on to the SPI protocol implementation testing. So far what we have learned about the TCP/IP protocol is we did not learn about the we did not go for implementing of the TCP/IP protocol, because the TCP/IP protocol is already implemented and available in an operating system network management services. So if you go for Windows operating system or Linux operating system or Android operating system or Mac operating system, not only these operating systems, but if you go to usually any operating system, uh, what we call big operating systems, you can say, these operating systems will have the services for network management. So under the network management services, the operating system will have the support for the TCP/IP protocol suite. So we did not have to implement the protocols in the process of learning TCP/IP. We just had to learn about the theory of TCP/IP and use the uh, use the use the implementation which is already there in the form of APIs, that is the socket APIs. Now here in this case, it is going to be different, because here we have to learn about the protocols, then we have to implement those protocols after learning, and we have to test the implementation whether our understanding of the protocol after implementing is working fine as expected or not, and then we have to go for application. So after testing the protocol, in what areas we can apply or use this protocol in the field of embedded systems. That is what we are going to learn. So today's agenda, right now you can see, are some things which you already know. So I don't have to waste much time here. So we have what is embedded system. So I'll quickly what we call revise that. So embedded system can be defined as a combination of hardware and software integrated onto a machine used for a controlled specific application. I repeat, embedded system can be defined as a combination of hardware and software integrated onto one system, which is used for a controlled specific application. This is one way of how we can define what is an embedded system. Another way of defining an embedded system is any system which is going to perform a dedicated task. Okay, any system which is going to perform a dedicated task, okay, controlled specific task or a dedicated task, is also referred to as an embedded system. So basically an embedded system makes use of either a microprocessor or microcontroller, mostly microcontrollers of course, and it is used for control specific applications. It's called as embedded systems. So examples of embedded systems are mouse, keyboard, cell phones of course, then you have controlling part of washing machines, controlling part of the microwave ovens, controlling part of the air conditioning system, controlling part of what we call refrigeration systems, security systems. So there are lots of what we call embedded systems out there crawling in the economy. Lots of embedded system devices are crawling inside the economy. Okay, so That's what embedded systems is about. Next, whenever we talk about embedded systems, so in the embedded systems, we may try to realize a communication between the CPU present on that embedded board along with its external peripheral components. We may try to realize some communication between the CPU, that is mostly a microcontroller present on the embedded board, target board, along with some peripherals connected on the target board, or else we may try to realize a communication between one embedded board and the other embedded board. So for that, we need to use what we call some sort of communication protocols. So mostly in the field of embedded systems, whenever we are trying to communicate between what we call the CPU and some peripheral components, or else some CPU embedded system and some other embedded systems, we will be trying to use some communication protocols. So it may be wired communication protocols, it may be wireless communication protocols. The agenda that we are discussing right now is about the wired communication protocols, and under the wired communication protocols, right now we are trying to discuss the serial communication protocols. So many serial communication protocols are being used in the wired communication protocols to communicate between CPUs on embedded boards and their peripheral components, or else between CPUs of one embedded board and CPU of another embedded board. So if we are trying to communicate between the CPU of an embedded board along with its peripheral components, we basically refer to such type of uh, communication as intra-circuit communication. Whereas if you're trying to communicate between a CPU of one board and a CPU present in another board, two different embedded boards, we can refer to that as an inter-circuit communication. A simple example again is, now if I'm having a cell phone and I'm connecting the cell phone to your desktop using a USB data cable. This is a simple example of an inter-circuit communication. Okay, it is an example of an inter-circuit communication. If I'm connecting what we call uh, on my cell phone itself, if I'm using a Bluetooth adapter, using Bluetooth, and I'm trying to exchange information with another cell phone, that is also coming under the inter-circuit communication. Via Bluetooth I'm exchanging information. uh, on your cell phone, you may have a CPU which is communicating with some sensors or components present on it. So that is basically called as an intra-circuit communication. So on a particular embedded board, if you are having components which the CPU is trying to communicate with using some form of serial communication, we can call that as an intra-circuit communication. But if there's a communication being taking place between a one embedded board and another embedded board using wired or wireless methods, it's called as inter-circuit communication. So what is a network? Network refers to an interconnection of two or more devices to accomplish reliable communication using one or more protocols. That is how we can try to define what is a network. What is a protocol? A set of rules, regulations, and standards to accomplish proper communication or guaranteed communication. That is about this. Okay, just one second. Next, we have what we call the low level or bus protocols versus high level. So whenever we talk about the low level or bus protocols, these are protocols in which rules, regulations, and standards are all considered when implementing the communication. We need to consider the rules, regulations, and standards. That means we need to consider the logical aspect of communication, which is the rules and regulations. Rules and regulations refers to the logical aspect of communication, and then we need to also consider the physical aspect of communication, that is talking about the standards. Standards here is talking about uh, wired or wireless medium. If it is wired medium, what are the wiring signals, what is the voltage levels of the wires, what are the length of the wires. Okay, these are all examples. What is the topology being used for communication? All this comes under the physical standards. So low level or bus protocols are those protocols which deal with logical aspect of communication as well as the physical aspect of communication. Whereas when we talk about the high level protocols, it only deals with the logical aspect of communication, and the physical aspect is not a concern for the high level protocols, because they will uh, have to take the help of any low level or bus protocols to do the same. Then coming down to the low level or bus protocols right now. In the low level or bus protocols, we have what we call bit banging method of communication implementation, as well as peripheral method of communication implementation. So the bit banging method of communication implementation implies that if a certain protocol is going to be implemented in a CPU, then if there is no hardware peripheral dedicated for managing that protocol operations, okay, there is no dedicated hardware peripheral to manage that protocol operations. That means there is no control logic to manage that protocol operations, but we are implementing that protocol operations using uh, uh, normal GPIO connectivity, normal GPIO lines we are using to implement that communication. Then we call that type of communication as bit banging method implementation. So without the help of any dedicated hardware logic, without the help of any special function registers, without any uh, hardware uh, peripheral dedicated to manage that communication protocols operations, if we are managing it using uh, software statements as well as common GPIO IO lines, then we call that as bit banging method of implementation. Whereas in contrast, if you're going for peripheral method of implementation, it's talking about the availability of a dedicated hardware logic with the support of special function registers, let us say. So this peripheral method of communication may be on chip or maybe off chip. Means you may have a peripheral uh, on chip inside a microcontroller, or you may have a peripheral being externally connected with a microcontroller, but the peripheral will take care of the communication, protocol communication, and we just need to configure it and give data to it and take data from it. But the rest of the uh, activity related to the protocols will be taken care by the peripheral. So such kind of method of communication implementation is called as peripheral method of communication. For example, in 8051, in 8051, you're having UARTs peripheral, which is having the set of SFRs called as SCON, PCON, uh, T mode, TCON, SBUF. Okay, like this, you're having these set of SFRs through which you have to uh, go for UART operations. So that is called as peripheral method. But suppose imagine that the UART peripheral is not available in your 8051 microcontroller. If the UART peripheral is not present in your 8051 microcontroller, and you have to realize the communication of UART's peripherals protocol, UART's protocol. If you have to realize the communication of the UART's protocol without the help of that hardware logic or special function registers, then that method of implementation is called as bit banging method of implementation. Then finally coming down to the concept, what is embedded networking. So embedded networking means any communication between an embedded between components of an embedded system and the CPU present in that embedded system. So if you take any embedded system, it will definitely have some CPU, maybe a microprocessor or microcontroller. So communication between the peripheral components and the embedded CPU can be termed as embedded networking. Or communication between two embedded devices can also be termed as embedded networking. Communication between an embedded device and a general purpose computer can also be termed as embedded networking. Okay, uh, so whatever protocol that is being used, if an embedded device is involved in the communication, we simply can refer to it as an embedded networking. So embedded networking can refer to usage of a simple protocol up to a complex protocol suite like the TCP/IP protocol. So if two cell phones are going to communicate using the TCP/IP protocol suite, still we can call it as embedded networking because they are communicating using TCP/IP protocol suites and they are embedded devices. Okay, guys. So far, I have given a quick revision about these terminologies. Any questions you would like to raise up till here, what I've discussed? Hello guys, am I audible? I have not discussed yet I2C. I have not started I2C yet. I have discussed till embedded networking. So till what I have discussed, do you have any queries you can ask? Bit banging method. It's not banning method. It's bit banging method. Bit banging method means realizing a communication protocol on a microcontroller, realizing a communication protocol on a microcontroller without the help of a dedicated hardware logic or SFRs, using normal GPIO pins and programmatic statements, is called as bit banging method. Yes, people. Can I go ahead if if no more questions?
Yes, sir.
Okay. So now coming down to what we call, so intra-circuit means basically on a particular embedded device, you will be definitely having a CPU. The CPU will be connected with some peripheral components. Examples of the peripheral components like memory chips like EEPROM, or it may be connected to RTC chips, or it may be connected to some kind of port expander chips, or maybe connected to some kind of sensor related chips. So if they are going to be connected between the CPU and those chips, communication is taking place on the same on the same embedded board. We can refer to that as intra-circuit communication. But if there's a communication taking place between one embedded board and another embedded board, we usually refer to that as inter-circuit communication. So USB communication between your cell phone and your PC through a data cable is an example of what we call inter-circuit communication. Communication between your 8051 kit and your desktop computer using UARTs cable and UARTs protocol, along with the RS-232 cable, is also an example of what we call inter-circuit communication. Communication between two desktop computers using Ethernet cable connected between two desktop computers can also be referred to as inter-circuit communication. Okay, guys, any more doubts? Okay, so I'm moving ahead now. Right. So the actual agenda starts from here. That is, we are going to have a discussion about the I2C protocol. So the acronym I2C, as you can see, stands for Inter-Integrated Circuit, and it refers to a synchronous serial communication protocol. What we mean by synchronous serial communication protocol is this is a kind of protocol in which between the connected devices, data will be exchanged. Apart from data, a clock signal also will be what we call involved. So data and clock are two entities which are going to be involved in communication between the devices. So you will have two devices which are interconnected with each other. The interconnected devices will be exchanging data based on what we call clocking signal. If there is a clock signal only, data will be sent from device 1 to device 2, as well as receive from device 2 into device 1, or exchange between the two devices only based on clock. If clock signal is given, if one clock signal is given, one data bit gets transmitted or received. If this next clock signal is given, one next data bit gets transmitted or received. So only if data is getting exchanged based on clocking signal, we call such type of communication as synchronous serial communication. Is this understood? The first point, synchronous serial communication is a type of communication in which the two devices are interconnected with each other such that they will be exchanging data along with clock. Means as a clock signal given, a data bit gets transmitted or received. Next clock signal given, next data bit gets transmitted or received. Next clock signal, next data bit transmitted or received. Subsequent clock signal, data bits gets transmitted or received. So if 10 clock signals, 10 data bits will get transmitted or received. Just what I mean like that. So it is based on data entity as well as clock entity. That is about the I2C protocol, which stands for Inter-Integrated Circuit, which is a synchronous serial communication protocol. So this protocol was actually designed or suggested by what we call the Philips Semiconductors Limited somewhere in the early 80s, and it was meant to allow communication between components which resided on the same board. That's what I mean by intra-circuit communication. So according to this protocol, since it's a wired protocol, this wired protocol supports a two-wired bidirectional bus. This I2C protocol is a wired communication protocol, not a wireless communication protocol. So it supports a two-wired bidirectional bus with the bus lines which are nominated as SCL and SDA, where SCL is not an abbreviation, but it can be uh, understood or interpreted as serial or synchronous or shift clock line, and the SDA line can be interpreted as the serial data line for transmission or reception of serial bits. Okay, that's about the third point. Then coming to that, the I2C protocol supports only half duplex communication. Now, what we mean by half duplex communication is at a point of time, only one device will be able to send while the other device receives, and vice versa. So here the SCL line is a line which is used for conveying the clock signal, that is the high low clocking signal, whereas the SDA line is used for conveying the data signal. So the data signal may be conveyed from one device to the other device or reverse case. But this data signal will be conveyed only based on what we call clock. If clock is given, clock signal is given, or clocking is given, then only data will be transmitted or received, otherwise not. So the I2C protocol supports what we call only half duplex serial communication. The bus length can vary from around 9 to 12 feet, which is around maybe somewhere you can say from about 2 meters, 2 to 2.5 meters, or like that. You can think of it in that way. Okay, if you just Google this, converting the 9 to 12 feet in terms of meters, maybe you'll be getting somewhere between 2 to 3 meters approximately there. Yes, V19H6A1 is asking a question. Sir, if you want to connect Node MCU with Arduino, Node MCU with Arduino, then I2C protocol will be there or SPI? Well, you have to check the specifications on the Node MCU pins. Arduino definitely supports I2C protocol. It also supports SPI protocol. It also supports UART's protocol. Okay, your I2C supports, Arduino supports I2C protocol, SPI protocol, as well as UART's protocol. We just have to check on the Node MCU whether it supports these three different protocols or not. And if it supports, then accordingly the connections can be made and communication can be
Sir,
made.
in this thing, if Node MCU is treated as a server,
Come again.
if Node MCU is treated as a server,
If Node MCU is treated as server, that's what is the sort of communication you are going for between Node MCU and the Arduino board? Is it an Ethernet based communication, or is it a Bluetooth based communication, or is it a UART based communication, or I2C based communication, or SPI based communication? You have to first decide what sort of communication is taking place. Is it a bus level protocol communication, or is it a high level protocol communication? If it is a high level protocol communication, excuse me, if it is a high level protocol communication, probably you may be using something like a Ethernet or Wi-Fi method of connectivity to communicate between Node MCU and Arduino. If it is high level, if it is the bus level,
sir,
probably you'll be using a UART or I2C or SPI.
If
like
we
that.
are using Wi-Fi connectivity, then which protocol will be there?
If you're using Wi-Fi, normally you'll be using some kind of apps. Okay, if you're using Wi-Fi connectivity, there is a possibility that you may be using some apps, or you may be using some support in the Wi-Fi. See, if a Wi-Fi connectivity is connected to uh, Arduino, Wi-Fi adapter like ESP8266 or any other adapter will be having a set of 80 commands. So you have to trigger the Wi-Fi adapter to send information and to receive information with the Arduino board using the 80 commands. That means
Sir, but in a Node MCU, there is a program, right, for it to modify as a server to make it act as a server in Node MCU.
Node MCU there is a program, but what about the Wi-Fi adapter that is connected to your Arduino board?
Sir, actually, I use this Wi-Fi adapter like my phone. I provided the network through my cell phone.
I didn't get you.
Sir, actually, then the Wi-Fi network was the Wi-Fi network was provided through my cell phone's normal
Wi-Fi
hotspot.
network, no, Wi-Fi
Hotspot.
network is provided by your cell phone hotspot. But how did Arduino connect to your Wi-Fi? How did
Yeah, yeah.
Arduino connect to your Wi-Fi hotspot? That's the question now.
Correct.
Can you tell me how did Arduino board connect to your Wi-Fi hotspot?
Actually, Node MC was connected to it, not Arduino.
Okay, you have not used Node MCU is connected to Wi-Fi hotspot.
Right, sir.
Okay,
And
so now first let us. Are you saying that Arduino is not being used right now?
sir, Arduino is also being used, but I think I had some wired connection, not I think Ethernet or something like that. Normal male to female connectors I've used to connect Node MCU along with Arduino.
You have used a wired connection to connect Node MCU and Arduino. Okay, so what is the wired connection method? Do you use Ethernet or did you use UART or I2C or SPI?
Well, I actually connected it, but I'm not sure whether I have used I2C or which would be applicable actually. And
One thing,
that's why I asked you this question.
one thing is, first of all, who did the project? Did you do the project?
Yes, sir, I did it, but it was long back.
Okay, so if you can't remember, then how I can help you? Because I told you you can connect Node MCU to your Arduino either using UART's connectivity or using I2C connectivity, using SPI connectivity, using what we call Bluetooth connectivity. So by connecting a Bluetooth adapter to your Arduino board, and maybe I think Node MCU is also having support for Bluetooth.
Yes, sir.
I've not worked on Node MC very much. I just know about it theoretically.
Sir, give me some time. I should rather go back and check in my thesis, and after that, I'll be surely back with you.
Yeah, better you do that. You first check it out in your record or thesis, whatever, and you can get back. Then we'll see at that.
Right, sir. Okay.
Okay then.
Thank you.
Okay. So as far as the distance is concerned for I2C protocol, it is recommended somewhere between 9 to 12 feet is a distance level which can be used for comfortable, communication without uh, much problems. Sometimes the distance can be increased beyond 9 to 12. For that, I think you may have to use some kind of repeaters or boosters for the I2C protocol, but very rarely people use that. Hardly people try to use I2C protocol with the help of boosters or repeaters because it is not preferred. I2C protocol is a kind of protocol which is preferred only for intra-circuit communication rather than for long distance communications. So even if you try to increase the distance of communication between 9 above 12 feet also, it can entertain, but some kind of extra additional hardware boosters should be required for that, which people don't really prefer. Okay, somebody is asking a question. Explain half duplex. Half duplex. See, we have basically communication as simplex, half duplex, and full duplex. So simplex communication is one device is sending, other device is receiving, and that is the only direction that is available in that communication. One device is the sender, the other device is the receiver, and that's the only direction. In the case of half duplex, one device at a point of time will act as a sender, whereas the other device will be acting as a receiver. At another point of time, the other device which was acting as a receiver will be now acting as a sender, and the previous device which was acting as a sender will behave as a receiver. We call this as half duplex. Coming down to full duplex, the two devices will have the capability to be sending and receiving. The two devices will be having the capability to be sending and receiving, because two separate channels or lines will be there for them to send and receive simultaneously or concurrently. That type of support is called as full duplex. Okay, V19H6A4. Okay, next V19H6K11 is asking a question, sir, GSM is high level or bus level? Well, GSM is coming under the physical communication technologies, so it comes under the bus level protocols. It does come under the bus level protocols, but these bus level protocols, when we are going for, likewise, if I'm going for a GSM modem or adapter, uh, it is a ready-made device which is already implemented major portion of the communication. To trigger the GSM modem for sending and receiving information, we just have to use a set of commands called as the AT commands. So already in a GSM modem, you will be having the protocol and everything implemented and in place. So it's a bus level communication or low level or physical communication only. Uh, we can think of it as a WAN technology also, like that. But we don't have to write the program for that WAN technology from scratch. Already the program is there inbuilt into the GSM modem. All we need to do is we need to trigger the GSM modem by a set of commands which we have to pass, and these set of commands are called as the AT commands. AT stands for attention commands. It is abbreviated as capital A, capital T, or sometimes small a, T. So AT commands along with some options are there. Using those options, you can trigger the operations of the GSM modem to send and receive using the GSM protocol. Okay, V1987K11. Okay, V19H6J2 is saying something that in Google, I2C bus length is given as 1 meter for 100 kilobits per second and 10 meters for 10 kilobits. Okay, 10 kilobaud. It could be like that. Yes, you will be having, based on certain speeds of communication, you will have distances. Fine. You will have, based on speeds of communication, you'll have distances. I also, just a moment. You can see over here in the next slide, I have that information, but I don't have the information about the distance, of course, but the speeds, yes. So you can see in the next slide, we have what are the different speeds, conventional or standard speeds that are supported by the I2C protocol. One is 100 kilobits per second, or it is also referred to as 100 kilohertz. Okay, 100 kilobits per second or 100 kilohertz. And the other one is 400 kilobits per second or 400 kilohertz. Then you have 1 megabits per second or 1 megahertz. You have 3.4 megabits per second or 3.4 megahertz, and you have 5 megabits per second or 5 megahertz. So 100 kilobits per second here is given as a standard mode of communication. 400 kilobits is referred to as fast mode, FM mode. 1 megabits is referred to as fast mode plus or FM plus. 3.4 is called as high speed mode, HS mode, and 5 megabits per second is called as ultra high speed mode or fast mode or ultra fast mode. You can think of that. So these are the different speeds. For these different speeds, there will be lengths, of course. There will be some lengths defined. I don't have the information about the lengths, but that is not really so much important, because up till now in the interviews they never have asked what are the lengths of the I2C protocol communications. They have mostly asked what are the conventional speeds. But okay, fine. If you can get the information on the Google about these lengths, so you need to check about 3 to 4 articles or 5 articles regarding comparing the speeds with the lengths, because from 4 to 5 articles there is a possibility that the the figures may change between 4 to 5 articles. So just have a observation on the internet and see what you can get. So somebody has said 100 kilobits, 1 meter, and for 10 kilobits. See, 10 kilobits is not a speed that has been given in my list. So from some article, you may also get some other information. Next, I2C protocol is referred to as a de facto standard. So the term de facto is actually a Latin word, I guess. So the term de facto here implies well established, well organized standard. De facto here implies well established or well organized standard. So there will not be very much fluctuation or deviation in this physical standard. So the slaves, I mean, the devices which abide by this protocol, I2C protocol, will not have to have much variation in terms of the protocol, because these devices will mostly communicate using the protocol in a well organized or well established way. That is called as a de facto standard. V19H7S8 is asking the question, sir, is it used for onboard communication? Yes, I2C protocol is preferably used for onboard communication. Okay, HE7S8. Okay, HE7S8. So I have given you the different speeds or standard speeds which are there. So just like in UART's protocol, you have conventional speeds like 9,600 bits per second, 4,800 bits per second, 2,400 bits per second, 1,200 bits per second, I think around 300 bits per second, 600 bits per second, something like that. 19,200 bits per second, 38,000 bits per second, or 37,000 something is there, 57,400 bits per second or something like that. So you are having different standards or conventional speeds in the UART's protocol. Similarly, in the I2C protocol, these are the standard or conventional speeds. But it is not must that this same standard speed or conventional speed must be used in a slave. So if a slave supports if the slave supports a maximum speed of 100 kilobits per second, still you can try to communicate with that slave at 10 kilobits per second, because the slave can support a maximum of 100 kilobits. So if you want, you can communicate with it with a slower speed of 10 kilobits per second or 15 kilobits per second, like that also. Okay, so that completes about this slide. Next, moving on to the next slide. So this protocol, I2C protocol, supports multi-master slaves communication. So what it implies here is it's a master-slave communication protocol in which the master is always any CPU. It could be a microprocessor or a microcontroller. Okay, I repeat, I2C protocol supports multi-master slaves communication. Here, multi-master slaves communication implies that the master is always a CPU. It could be a microprocessor or microcontroller. That microprocessor or microcontroller may support on-chip support for I2C or may not support on-chip support for I2C, but the master is always definitely a CPU. Slaves, on the other hand, in this protocol mostly will be peripheral devices, but sometimes there may be some slaves which can also be some other CPUs which have been configured to behave as a slave. So usually when peripheral devices are there, mostly the slaves will be the peripheral devices. And when you talk about CPUs which are having inbuilt support for I2C protocol or I2C protocol dedicated logic or peripheral, then such kind of CPUs can be configured to behave as slaves. Okay, V19H7R1 is asking a question. Sir, I2C is used for board communication. Then why it is called as inter? I2C protocol is used for onboard communication. So onboard communication, the terminology for onboard communication is not inter communication, but it's called as intra. Intra means within the same circuit. Inter means from one circuit to another circuit. Okay, HE7R1. Okay. Next, coming to the next point in the I2C protocol is, since it's a serial communication protocol, what is the serial byte order for sending information from master to slave and getting information from slave into the master? So the serial data transfer order is most significant bit first. Any data that is going from master towards slave or being received from slave into the master, it has to come in the serial bit order as most significant bit first. Okay. Next, the I2C protocol supports a small level of handshaking in the form of acknowledgement, signal, or state. That means for every 8 bits of data communicated from master to slave, uh, slave uh, slave will give an acknowledgement status to master that it has got 8 bits of information. Similarly, if any 8 bits of information are collected from slave into master, master can give some sort of status or acknowledgement to indicate that it has got 8 bits from slave into it. So this type of handshaking is simply called as handshaking in the form of acknowledgement, signal, or state. Then coming to the last slide, in which the points are given as, since I2C protocol, as I already mentioned, supports master-slave communication protocol, excuse me, it supports multiple master-slaves communication protocol. So how does the master access the slave in this communication protocol? So every slave that is being accessed by a master, see, master slave communication protocol, multi master slaves communication protocol also implies like this: you can have one master, one slave, you can have one master, multiple slaves, you can have multiple masters, one slave, you can have multiple masters, many slaves. So master is the one that initiates the communication, master is the one that mostly manages the communication, master is the one that terminates the communication. So slave is just simply a sitting duck. It will only speak when it is asked to, it will only speak when it is asked to speak, otherwise not. So speak when asked to be spoken, otherwise not, like that. So whenever any master wants to access a slave on the I2C bus, then every slave is accessed using uh, a specific address. Every slave connected on the bus should be having a unique address of its own, so that the master can identify that slave and address that slave and communicate, that is send receive with information with respect to that slave. So it supports slave access or slave selection or slave identification using a kind of addressing method. So there are two addressing methods supported in I2C protocol. One is called as the 7-bit slave addressing method, in which theoretically you can have support on one bus for 2 power 7, that is about theoretically 128 slaves can be connected on one bus, but practically it will be about 110 or 12 slaves, because some of the slave addresses are reserved and are not allotted to slaves. Slave access means addressing the slave. Slave access means addressing the slave or accessing the slave for sending data and receiving information or communicating with it. Then we have the 10-bit slave addressing. Just a moment, please. Okay. 10-bit slave address is an extended addressing scheme that was introduced later. Initially, when I2C protocol had been introduced, it was only having support for 7-bit slave addressing scheme, which were able to support theoretically up to 128 slaves on one bus. But later, based on demand for this protocol and appreciation for this protocol, the addressing scheme had been increased to support more number of slaves on the bus. So in that way, the 10-bit slave addressing had been introduced. So 10-bit slave address means, theoretically speaking, 2 power 10, which is 1024 slaves, 1024 slaves, theoretically speaking, can be connected on one bus. Next, the I2C protocol supports broadcast communication as well as unicast communication, but there is no support for multicast communications. Unicast communication is a one-to-one communication. Multicast communication is one-to-many communications. Broadcast communication refers from one to all communications. Okay, V19HE7S8. Unicast means one-to-one communication. Multicast means one-to-many communications, and broadcast means one-to-all communications. So in unicast, one sender, one receiver, and again the receiver can behave as a sender and the sender can behave as a receiver. In multicast communication, you'll have one sender and many receivers. You'll have one sender and many receivers. In broadcast communication, you'll have one sender and all receivers in that way. Is this understood? V19HE7S8. Okay, guys. S8, I didn't understand you what you're saying. Many means any particular. What do you mean by many? Many means any particular. In multicast, one to many. So there is no particular number for that. There is no particular number. Of course, I2C protocol does not support multicast. Let me be clear with that. I2C protocol does not support multicast communication. It supports broadcast as well as unicast, but not support multicast. Multicast means one to many communication, so that many, of course, right now is not supported in I2C protocol. So there's no point of discussing on that further because it's not supported at all. Okay, guys. So that completes, I think, today's discussion, introductory discussion to I2C protocol. So I'll not further proceed today. So today was just a starting day. We'll stop here today. Any questions from your side regarding this introduction? In the I2C protocol, when a master wants to communicate with a slave, so the slaves will be having what we call, every slave that is connected on the I2C bus should be having a unique address. There should be no two slaves connected on the bus which are sharing the same address. There should be all the addresses connected to the same bus should have a unique address. So when different types of slave were being designed in the electronics industry, okay, so the total number of slaves that could be designed to support 7-bit slave addressing had got exhausted. So there were no more uh, slaves that could be designed to support 7-bit addressing, but still people wanted to have new kinds of slaves manufactured in the electronics industry, which could be part of the I2C protocol I2C bus protocol. So they had to uh, design slaves with new level of addressing. That's when the thought of why not increasing the addressing capability of I2C protocol. And then there was a modification in the I2C protocol to support also 10-bit slave addressing, so that slaves can be designed by the manufacturers for supporting 10-bit addressing, and they can be part of the I2C bus communication also. So just uh, to increase the number of slaves that could be connected on the I2C bus, to increase the choice of the number of slaves or the varieties of slaves that could be connected on the I2C bus, the concept of 10-bit slave addressing had been introduced. Okay. Okay, guys. Any more questions, right? That's it for today then. You can leave. Thank you.